first step of the experiment to close the glass with the cardboard. Next, we turn the glass of water upside down. Then, as you can see, the cardboard is stick to the glass water because it's being pushed by the atmosphere pressure. Then, how it happened? Let's calculate. This is the theory behind upside down glass water. The experiment is related to air pressure. The air pressure is pushing up on the cut from below while the water is pushing down on the cut from above. The force on the cut is just the pressure times the area over which the pressure is applied. That's the definition of pressure. How the water do not spill? In this experiment, the air pushing up from underneath the paper is strong enough to overcome the weight of the water pushing down on the paper. Because of the air pressure pushing up on the cut will stay on the glass and the water will not spill out. Next, the calculation related. We use the Boyle's law equation and force pressure equation to calculate the pressure outside and inside the glass. The calculation is needed to show that the pressure outside is bigger than the inside. Then, let's start the calculation. Let's go.
So before the experiment start, there is 0.5% gap in the glass before the experiment start. So if 100%, there is 275 milliliter, and 0.5% equals to 1.375 milliliter. After the experiment, there is 1% gap in the glass, which is 1% equals to 2.75 milliliter. So you want to calculate the after the experiment's volume. So 275 milliliter minus 2.75 milliliters equals to 272.25 milliliter. So first step, we must calculate the mass. For the mass, the formula is density times the volume. So we put the value 100 kg divided by meter cube times 272.25 exponent negative 6 equals to 0.27225 kilogram. For the force, the formula is mass times the gravity. So we have the mass, which is 0.27225 kilogram times the gravity, which is 9.81 meter per second square. The total is 2.6708 Newton. Next, we will use Boyle's equation. P1V1 equals to P2V2. P1 equals to 1 atm. The value is 101.325 Pascal, and V1 equals to 0.5%, which is the value is 1.375 centimeter cube. And we can change it into the meter. So the value is 1.375 exponent negative 6. For V2, which is after we done the experiment, it is 1% gap in the glass. So 1% equal to 2.75 centimeter cube, and change it into the meter. So the value will become 2.75 exponent negative 6 meter cube. Then find the P2. P2 equals to P1 times V1 divided by V2. So the value is 101.325 times 1.375 exponent negative 6 divided by 2.75 exponent negative 6. So the total is 50663 Pascal. So the area of glass is pi times 2r squared, which is the radius of the glass. So pi times 2, 3.75 squared, and the value that we got is 4.4179 exponent negative 3. After that, use the force pressure equation. First, we must find the force pressure inside. So the equation is pH plus P2 times with area. So for finding the pH, which is the hydrostatic pressure, the equation is rho GH. So the rho is the density of water 1000 times with gravity 9.81 and times with the height of the glass, which is 0.13 meter, and the answer is 1275.3 Pascal. So for the force pressure inside, the equation is pH plus P2 times with area. pH that we got is 1275.3 Pascal plus with the P2 50,663 times with area 4.4179 exponent negative 3, and the value is 229.458 Newton. And the last one, for the force pressure outside of the glass, the equation is pressure atmosphere times 2 area. So as we know, the pressure for the atmosphere is 101325 times with the area 4.4179 exponent negative 3, and the answer 447.644 Newton. And from there, we know that force pressure from the outside is more than force pressure inside the glass.
Hi and Assalamualaikum. So for question 2b, a question required us to choose one real-life product or process and explain one or more of the fluid mechanic application that involved in that product. So our group decide to choose thermal power plant. What is fluid mechanic? Fluid mechanic is the study of fluid flow which is used to analyze various applications involving liquid bodies. Liquid are used to quantify the pressure of a liquid in motion. Liquid body equilibrium analysis, in which fluid exert force on the system. It is also included in fluid mechanics. Fluid is material that deform continuously when subject to shear stress, a substance that can flow. Example, water, oil, and others. Then, mechanics is study that deal with the motion or force on object. In this context, an object refers to particle that either stationary, which is static, or moving, which is dynamic. So, what is thermal power plant? A thermal power plant is a generator of electricity. In addition to generating electricity, some thermal power plants are designed to generate heat for industrial application, district heating, or water desalination. Mechanics that are used in thermal power plant is Bernoulli principle. In fluid mechanics, Bernoulli principle asserts that an increase in a fluid speed could occur with a drop in pressure or a decrease in the fluid potential energy. The concept is named after Swiss scientist Daniel Bernoulli, who published in his book Hydrodynamics in 1738. The venturi tube is a practical use of Bernoulli principle. The air entrance narrow to a throat in the venturi tube, and the output section grow in the diameter toward the back. The outlet diameter is the same as that in the inlet. The mass of air entering and exiting the tube must be exactly equal. The speed must rise at the constriction to allow the same volume of air to travel in the same period of time as in the rest of the tube. When the air moves faster, the pressure drops. The air flows slow and the pressure rises after the constriction. So, this is the layout of the thermal power plant. There are several applications of thermal power plant. We can generate electricity by rotating the generator shaft. The steam turbine provides movement to the generator. We need high pressure steam and high temperature at the turbine inlet to start the steam turbine. The Bernoulli principle is used to start the steam turbine. When a turbine absorbs energy from a high energy flow, the fluid pressure and temperature drop as it approaches the outlet. Multi-stage steam turbines, such as increased pressure, medium pressure, and low pressure, are often used in high-capacity power plants. Next is condenser. The condenser is used to cool the working fluid, or in the other word, to extract the heat from the water. Cool water circulation is used to condense the enhanced steam in the condenser. The steam loses its pressure and temperature and transform back to the water. Condensing is necessary because compressing a gaseous fluid demands a large amount of energy compared to compressing a liquid. As a result, condensing improves the cycle efficiency. This process involves turbulent flow. Okay, that's all from our group. Thank you.